So we've learned how to solve quadratic equations. We're going to use that idea to solve quadratic inequalities. So we're going to, we're going to kind of factor our equation if possible. And I think for all of your 6 homework problems for this, I did make them factorable. You could always use the quadratic formula if you had to. We'll replace the inequality symbol with an equal sign, and then we'll use the, I think, a zero product rule. I cannot remember what it's called. To solve for x, it's where we set each parenthesis in our factor equal to 0. We'll then graph and test points to help us graph. So there's some steps to solve inequalities. We're not going to graph the whole quadratic equation. We're just going to graph what it looks like on the number line or the x-axis, giving us what x values or what domain values are actually reasonable for this inequality. So when we're solving these, we're solving for their domain. The first one I have for you is already factored, just like the first couple of problems on your homework. So we have x plus 3 and x plus 2 is greater than 0. So I'm saying set these equal to 0 like you would if you were solving them. That way we can use this theorem here to tell us that x is negative 3 and x is negative 2. Now, you don't have to do this work over here. I want to show you what this quadratic equation looked like. It used to be x squared plus 5x plus 6 before it was factored. So on the graph, it goes through negative 3 and negative 2, and it's positive, so it looks something like this. So what I'm trying to do is decide if it's shaded in the middle of the quadratic function or if the shaded region is on the outside of the quadratic function. To do that, you test points. So I'm going to take just the x-axis here, and that's what I'm going to graph. That's what's on your homework. So we're going to draw our number line, or our x-axis. Label some points here. We have 0, 1, 2, negative 1, negative 2, negative 3, negative 4. The points we found have a greater than symbol, not a greater than or equal to symbol. So they're going to be open points on my number line at negative 3 and negative 2. Now I'm essentially checking, is it shaded in between the points or shaded on the outside of the points? So I'm going to try 0. Now you should technically try negative 4, negative 2.5, and 0, but because it's symmetrical, you should always have a symmetrical shading. The only time that I would be careful of this is if you have just one answer point, meaning we only have one x-intercept. But I'm going to try just 0 to show you what I'm talking about. What I'm going to do is, by trying a point here, plug in 0 to my original equation and see if I get a true or false answer. Ooh, I am struggling. There we go. Try 0. So we're going to put 0 in to my x and see what the output's going to be. So that is 3 times 2, which is 6. So is this statement true or false? Is 6 greater than 0? This is true. Because it's true, that's the area that's shaded. If it was false, then I'd know the opposite area is shaded. So what I just found out, oh goodness, there we go, is that my shaded region looks like this. So this is the domain of my graph. So I'm looking for you to graph it and to write your answer in interval notation. Because it's pointing outwards, that means that I'm going from negative infinity to negative 3. And it's not included, so I'm using a parentheses. And, or, oops, just Just struggling over here. There we go. We have another excluded point at -2 to infinity. Okay, so I'm looking for your graph and I'm looking for your interval notation of the shaded region. Okay, I'm going to do a couple more, but I want you to notice right here that this was a greater than symbol, so we shaded in the outside area. The pattern will hold true. I'm going to take a look at another example. This one is not factored, and it only has 2 terms. And it's also going to be included because of the less than. When you only have 2 terms, I need to find the greatest common factor. So their common factor, they both have an x. So this is my factor here. Now anytime you have an x on the outside, x is equal to 0, and then I'm going to skip the step and just say that we know that x is positive 5. Because remember, they change signs when you set it equal to 0. So we have 2 answers, x is 0 and x is 5. So I'm going to graph those. I'm going to kind of cheat here. Your number line is made for you. I'm just going to put some points on mine. Okay, so I'm going to put a closed circle because there's a line, an equal sign in my inequality symbol, a closed circle at 0 and a closed circle at 5. Now when you're testing points, do not test your answers, especially if it's closed, because you'll get true and then you won't know what to shade. Now I'm going to test a 1 this time instead of 0 because 1 is between 0 and 5. There are other numbers here that I could test, but I'm going to test 1. And I'm going to plug it into my original equation. So 1 squared minus 5 times 1. If this is less than or equal to 0, then I'm going to shade in between. So 1 minus 5, so -4. Is -4 less than 0? Yes, it is. So I'm going to shade the region in between my 2 points. This was true. Okay, so I had a less than, which means I need to shade in between. My points are included, so I need brackets, and my answer ends up looking like this. So if you're shading in between, you do not use the infinities. You should just have your 2 answers and then either a bracket or parentheses depending on the inequality symbol. Okay, now, less than or equal to symbol, shaded in between. Funny, my greater than was shaded on the outside. I wonder if that pattern is going to hold. Let's try another problem and find out. I have 2 more for you. If you got it, you got it. You can try your problems. If not, I do want to do 2 more problems for you. So in this example, we have x squared minus 4x minus 12 is greater than or equal to 0. So if our pattern holds, it's a greater than symbol, it should be shaded on the outside. But let's work it out and try. Now we're getting to a point where you should be able to factor this in your head. I did teach you how to use the t-chart and factor it, but you should know some multiples of 12. So the common one is 3 times 4. Is 3 times 4, when we add it together or when we subtract their differences, going to give us 4? No. So I would try maybe 6 and 2. 6 times 2 is 12. And then remember the sign in the middle keeps with the bigger number. So is -6 plus 2 -4? Yes. So I know that to factor this one, I get x plus 2 and x minus 6. And then my solutions, change the sign, and x minus 2 and x equals 6. So on the number line, or on our x-axis here, it looks something like this. And let's check them. They are equal signs here, so we're going to close in our circles at -2 and 6. And now we need to see if 0 is included in our answer or if we need to test other points. So I'm going to try 0. And you can plug it into the factored form or you can plug it into the original equation, whatever one works for you. We just want to know if this is true or false. So I have -12 is greater than or equal to 0. Unfortunately, this is false, and our pattern holds true. We should be shading in the outside, including the infinities, just like in the problem before with the greater than. So my answer, -infinity to -2, this time with a bracket because it's included, or 6 to positive infinity. Okay, now on your homework you have a couple that don't have the right-hand side equaling 0. So what you're going to do is move them over to the left-hand side and solve. So I want to have one more example so I can show you that, just in case you need it. What I'm saying is, if you have something like this, where the right-hand side doesn't have a 0 in it, we do need to move that number to the other side by using our inverse operations. So we have x squared minus 5x minus 6 is less than 0. Now that this side is equal to 0, we can start factoring. So that gives me, I think it's 6 and 1. Let me check. The middle sign is negative, so my 6 would be negative. So -6 plus 1 is -5. That's exactly what I was looking for. So that tells me that x is 6 and x is -1. Okay, so on my graph, we're going to do, let's see, -1, 6. Now, I can't use -1, and I can't use 6 to try to see where it's shaded, but I can use 0. And notice that I used open circles because there's no equal sign in my inequality symbol. I'm going to try the point 0, and I'm going to plug it in, not to the original equation, but the one that's solved, so that I don't have to do anything weird. Oh, look at that. I told you I was going to plug it in, and then I forgot. So we have 0 squared minus 5 times 0 minus 6, and we want to know if that's less than 0. So I want to know if it's a negative number, less than 0. So 0, 0, -6, less than 0. This is true. Because this is true, that's the area that I'm shading. I need to make sure 0 isn't part of my answer. So we have something like this. And then, because it's shaded in between -1 to 6 with parentheses this time, because they're not included. So, yes, it holds true that if you have a less than or equal sign, you're going to be shading in between 2 points. If you have a greater than or equal sign, you'll be shading on the outside of the 2 points. So your graph should start to look like this. So that's a nice cheat to remember that if you need it. Okay, if you have any questions, reach out to me. I have another video for you.